All right, on to chapter 3.4 where we find solutions to polynomial functions. Those solutions are also called zeros because they are graphed on the x-axis. The first example is they ask us if x plus 2 is a factor of the polynomial starting with x to the third. And the best way to figure this out, look, if it's a factor, if we can write it as a multiplier, then we can, if it's a factor, it will divide, x plus 2 will divide that polynomial evenly. And the book, if you're interested, the book will show you how to do long division with polynomials. I tend to only use synthetic division. So on the quiz, if they ask you to do long division, I recommend synthetic division. It's a lot faster, a lot easier, and error mitigates errors, less errors. So I'm going to use synthetic division for all of them. There is a use for long division, but it doesn't show up in this chapter. So the way we do synthetic division is, a reminder, hopefully you've seen it before, is we set up a half a rectangle. And in the top half of this rectangle, we're going to put the coefficients of each term. So x to the third term, my x squared term has a coefficient of 8, x term has a coefficient of 21, and my last term is 18. On the outside, I'm going to put my possible 0. Now, they gave me a factor, so I have to remember to change the sign. So we're going to actually divide out a possible 0 of -2. And the way we do this, synthetic division, the first thing we do is just pull down our first coefficient. And then we multiply -2 times 1. And then we combine positive 8 with -2, get a 6. And -2 times 6 is -12. -12 plus 21, it looks like it's a positive 9. -2 times 9 is -18. And when we combine the positive 18, -18, we get a 0, which means definitely x plus 2 is a factor of the second polynomial. Now they're asking us to factor it completely, so I need to write this as this polynomial, x to the third plus 8x squared plus 21x plus 18, as a multiplication problem with x plus 2 as one of my factors. And now I'm going to use these 3 coefficients to write the rest of it. I just divided a cubic, x to the third, by x. When you divide x to the third by x, you're going to get x squared. So I'm going to start with the 1 here. I'm not going to write it because we usually don't, as 1x squared, and then plus 6x plus 9. This is my completely factored polynomial, and one idea that gets us to zeros is that it has to be equal to 0. The quadratic I wrote on the right is also factorable, so I'm going to fully factor because they asked us to completely factor this polynomial, x plus 3 times x plus 3, which, if you want to, you can write as x plus 3 squared. I like doing that because there's my fully factored polynomial because it's just less typing. Okay, on to example 2. It says to use the rational zero theorem to find all possible rational zeros. Now, what this does is it gives us a place to start our synthetic division if we don't have any other way of knowing. Honestly, though, usually I'll throw this into the calculator and get my possible zeros from the calculator. As long as they're integers, that's easy to do, but if they're not, this theorem comes in handy. So what the rational zero theorem says is that all the zeros of this function are going to be p over q. Now, p is my constant, so there's my p. Q is the coefficient of my highest degree term. So if I look at these numbers, and by the way, it's either plus minus. It's always plus minus, in spite of the fact that it doesn't matter what sign p and q are. We always consider both positive and negative. So my factors of 6 are 1, 2, 3, and 6. So in the numerator, I'm going to put all of the factors of 6, and I'm going to put my plus minus in front, over the factors of q, which is just 1. It makes it fairly simple. So my possible zeros here, the only numbers that I would like to, that I would even try to divide out, are going to be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So if you don't have any other idea on where your zeros are, it's a good place to start. Okay, on to example 3. And I need to change example 3. It looks like I did. Okay, on your notes, though, you're going to have a 4 here. And it doesn't work out the way I want it to, so I changed it to a -1. So please change your notes to a -1. So the question is x minus 2 a factor of this polynomial? Well, in order to find that out, we just set up our synthetic division again. So I have 1x to the third, -1x squared. I don't see an x term, so I have to fill in a 0. If you have any missing terms, fill in a 0 coefficient, and then my last number is 1. And the reason I had to change it is because if I didn't change it, then it would work out the same as the following problem, and I wanted you to see 2 different results. All right, so I'm going to use the factor of -2, change the sign. I'll get a 2. Pull down my first coefficient of 1. 2 times 1 is 2. -1 plus 2 is a positive 1. 2 times 1 again is 2. Pull down the 2. I get 2 times 2, which is 4. Now when I combine 1 and 4, I get a 3. Because it's not a 0, then x minus 2 is not a factor. Now, if you don't get a 0 and you really think it should be a factor, go back and look at your math. Look for missing coefficients or maybe a minor math error. All right, that's it for this video. I'll see you on the next one.